Next, we are going to learn the various crystal classes and the various types of unit cell possible for them. The total number of various crystal classes are 7. And that's why you can see here the heading topic is 7 primitive unit cells in crystals. So what are they? The first one is the cubic type. In cubic type, the axial distances is A is equal to B is equal to C, and the axial angles is alpha is equal to beta is equal to gamma is equal to 90 degree. And the various possible type of unit cell in this crystal class is 3. In the cubic type, 3 types are possible: primitive, body centered, and face centered. End centered is not there in this one. And examples are sodium chloride, zinc blend, copper, etc. The cubic crystal system is also known as isometric system. All the sides of same length and angles are of same length and angles between the faces. That is, all are 90 degree. The cubic system has one lattice point at each of the cubic's 4 corners. The second one is tetragonal. In tetragonal, A is equal to B, not equal to C. But alpha is equal to beta is equal to gamma is equal to 90 degree. It is clearly given in your NCERT textbook. You can go through it also. There are 2 types possible for this crystal class. It's primitive and body centered. As I had mentioned here, A is equal to B is not equal to 0, but alpha, beta and gamma are same as above. It is 90 degree. Example is given here: calcium sulfate, SnO2, TiO2, etc. A tetragonal crystal is a simple cubic that is stretched along its axis to form a rectangular prism. One side different in length to the other 2, and angles between faces all 90 degree. Next type is the orthorhombic. In orthorhombic, A is not equal to B, B is not equal to C. And the angles all are 90 degree. Alpha is equal to beta is equal to 90 degree. There are 4 types actually here: primitive, body centered, face centered, and end centered. As I had mentioned here earlier, edge length is given, the axial angle is given. Example: rhombic sulfur, potassium nitrate, barium sulfate, etc. Next is the hexagonal type. In hexagonal type, A is equal to B, not equal to C. While alpha and beta are 90 degree. Alpha is equal to beta is equal to 90 degree. Gamma is 120 degree. So the shape will be different. So this is the hexagonal type of crystal class. And only one possible variations or possible type of unit cell is here in this class. It is the primitive. The angles and edges I have mentioned earlier. Example: graphite, zinc oxide, and cadmium sulfide. These I have mentioned. You can simply read this. Next is the rhombohedral. Trigonal or rhombohedral. In trigonal or rhombohedral, A is equal to B is equal to C, and alpha is equal to beta is equal to gamma not equal to 90 degree. The possible type of unit cells is primitive. Only one type is there under this one. Examples are calcium carbonate, HGS, mercuric sulfide, etc. The next is the monoclinic type. Monoclinic type, A not equal to B, not equal to C. Alpha is equal to gamma is 90 degree, while beta is not equal to 90 degree. These type of crystals in which all these angles are in this pattern, in this way, that type of crystal class is called the monoclinic type of crystals. And the possible types of unit cell or possible variations present in this type is only primitive and end centered. Examples: monoclinic sulfur, which you have learned in the P block, sodium sulfate, etc. And the last one is triclinic. In triclinic, A is not equal to B, not equal to C, while alpha is not equal to beta, not equal to gamma, not equal to 90 degree. And the only possible type of unit cell present under this crystal class is primitive. Only primitive type of unit cells are present. Edge lengths as given. Examples: potassium dichromate, copper sulfate, etc. Now there are 14 three-dimensional lattices altogether. These 14 different types of lattices are known as Bravais lattices. The unit cell for these 14 lattices is what is given here. Altogether, the total number is given here in the picture. You just need to understand the basic knowledge is only required for this.